Hello everyone, welcome to my channel. My name is Dr. Yogita Bish and this is my first video of this channel, and first I would like to tell you why I have created this channel. A little bit short introduction of my channel. The reason why I have created this channel is that I have experience of teaching both college students as well as school students, and one thing that I have realized is that even at the college level, even in masters and PhD, there are many students who struggle with the basic concepts of the chemistry. Sometimes sometimes they find it very difficult to work in lab. The reason being is they don't know how to apply the theoretical knowledge into the practical knowledge, and sometimes they are they can solve the complicated problem, but they struggle with the basics problem, right? So it is very important to get their concepts clear. Then only you will be able to solve the simple as well as the complicated problem, and at the same time you will be able to use that knowledge in the real life and as well as in the lab. Later on, when you decide to go for PhD or maybe some other research, you should be able to use those concepts in your field, right? So with the help of this channel, I would like to explain, or rather I would say I would like to fill that gap. All right, so in the very first video I'll teach you like how to prepare the basic solution in lab. Okay, and if you don't understand anything in this particular video, please don't worry. Okay, because everything that I'm going to explain here, like the molarity and all those things, I'm going to teach these things again from the basics, like what is mole concepts and all those things in the next subsequent video. So you can just think it as a beginning of exciting chemistry journey. All right, so let's just start with this. Okay, so I'll start with a simple question. Like, this is something we do ask normally in labs. Let's say in your lab somebody asks you to prepare n by 40 solution of NaOH, very commonly prepared solution, right? In, let's say, 250 ml standard flask. I'll come back to this part later on, what is standard flask or what is conical and all those things, in which apparatus should we prepare solutions. Some of you may find, okay, in our lab the lab attendant do this work, we don't need to. It's wrong. You should know how to prepare this solution. Instead of n by 40, if I ask like prepare m by 40, will you be going to follow the same procedure? Let's say if in case I ask you to prepare n by 40 of oxalic acid, will it be same as m by 40 of the oxalic acid? No, it will not be, right? So there are very small things that you should know, right? So a lot of time students find even this simple problem very difficult, and whereas if I ask them to solve this in terms of numerical, let's say if I tell them that this is the normality, this is the volume, and this is this, please find the number of moles, then maybe they will be able to do that. But I don't know why they are unable to replicate this in the lab, right? So we are going to study that here. All right, so let's say here what we have to do is we need to first find out how much weight, mass of NaOH that we need to dissolve in 250 ml of the water. Not exactly 250 ml of water, I'll tell you like in how much volume we are supposed to dissolve this. But first we need to find out what is the mass of NaOH that we need to weigh, right? For this, you know the formula, right? The basic formula. Molarity is equals to number of moles divided by per liter of the solution, that is volume in liters. But here we are supposed to calculate make n by 40 rather than molarity. So n is nothing but number of gram equivalent divided by volume in liter. Now in this particular case, normality is same as that of molarity for NaOH. So it doesn't matter, like whatever the volume weight we are going to calculate, it is going to same. Reason being is there is a difference between normality and molarity, because here the replaceable OH ion is 1. Here OH ion is 1. That is why in this case normality and molarity doesn't matter. But it is not always the case. And we always work with normality rather than molarity. Please remember that. So it will not make any difference in case of HCl. It will not make any difference in case of NaOH. But in case of oxalic acid, it is going to make all the difference. Okay. So these complicated things we are going to study later. Okay. So let's first calculate the equivalent weight of NaOH. So the formula for equivalent weight is molecular weight divided by N factor. So for NaOH, we know that N is 1. Why? Because for NaOH, we have replaceable OH negative ion is equals to 1. Similarly, if we talk about some acids, for example, HCl, here the replaceable H plus ions are 1. So for HCl also, N is equals to 1. For oxalic acid, the replaceable H plus ions are 2. That's why the N factor is 2 for the oxalic acid. So this is very important to remember. And I'll make another video for detailed video for this particular concept, how to find the N factor. Okay, so molecular weight of NaOH is 40 grams per mole. Therefore, equivalent weight is 40 divided by 1. Now, we can calculate the amount of the NaOH that we require to prepare the N by 40 solution using the formula. So, we know that normality is equals to number of gram equivalent divided by volume of solution in liter, total volume. Alright, and formula for the number of gram equivalent is given weight, that is the weight of NaOH that we are supposed to calculate to find out how much NaOH we are supposed to dissolve, right, divided by equivalent weight. It is the formula for the number of gram equivalent. Rest remains same. So multiplied by volume in liter, and this weight will be in gram. Okay. So we can put all the values. So here we know that normality is 1 by 40. Given weight we are supposed to calculate, divided by equivalent weight we have already calculated, 40 divided by 1, and the volume as per the question we are supposed to make it in 250 ml solution, right, total volume. So it will be 250. Now since this is in ml and we are supposed to do it in liter, that is why we need to convert into liter by dividing by 1000. Okay. And these conversions are also very important. So if you don't know these conversion, I'll make another video for this, and where I'll explain all the important conversion that you must know by heart to solve any numerical in physical chemistry. Okay, and there are repeated conversion that you must know. So it's not that difficult. Okay, so we are going to do the calculations. So this will be 4. So given weight will be 1 by 4, which is 0.25 gram NaOH. So this was about the calculation. That means we have to weigh 0.25 gram of NaOH to make a solution of N by 40 NaOH in 250 ml standard solution. Okay, so this was about the numerical part. Now comes the practical part, how to do that. Okay, so first, before we start the practical thing like procedure, you must remember one thing, that no matter what how accurately we are going to measure the NaOH, there will always be some kind of discrepancies. So basically what happens is, like, NaOH is not a primary standard solution, it is a secondary standard solution. Okay, so let me just write something. NaOH is a secondary standard solution. So what is a secondary standard solution? It is a solution which cannot be accurately weighed. Okay, why? Because it is hygroscopic in nature. It has the tendency to absorb moisture from the air. That is why if you are going to weigh 0.25, the amount will not be accurately 0.25. Okay, so you will always end up with a little bit lesser amount of the NaOH. Why? Because it is going to absorb some amount of moisture. That is why even after preparing, doing all the calculation correctly, transferring exact amount in the standard flask, and adding exact amount of the water, still you will end up with not exact solution. That solution is secondary standard solution. To exactly find out the strength of that particular solution, you have to titrate it against the primary standard solution. These are the small concepts, some easy concepts. Sometimes students tend to ignore, and they just use directly whatever the end solution they are being provided with. Okay, but if you are aiming for the accuracy, do remember NaOH is not a primary standard solution. We have to standardize it against some other acid, for example oxalic acid. Oxalic acid is a primary standard solution. Whatever amount we are going to weigh for the oxalic acid, and if we are careful about the volume of the water we are adding, then we are going to get exact strength of the oxalic acid solution. Okay, so I'll make another detailed video, don't get confused right now, regarding this, what is primary standard solution, what is secondary standard solution. But as of now, just remember one thing, that NaOH has a hygroscopic in nature. That's why it has a tendency to absorb some amount of water from the solution. All right, now let's just move to the practical part, how to do this. Okay, so first of all, what you have to do, you have to weigh 0.25 grams of NaOH. Try to be as accurate as possible, but most of the time it's not possible. Reason being, the moment you are going to try to weigh this, it will start absorbing water, and it's a little bit corrosive in nature, so you have to be a little bit quick. Okay, so try to be as accurate possible, but don't wait too much for this. All right, and then what you have to do is, you have to take a standard solution. We always make solution in a standard solution, not in conical, nothing, but in a standard solution. So somewhat this is how it look like, a standard solution. Normally we have this in 250 ml or in 100 ml, but in 50 ml or 500 ml also possible. So for this particular question, we are supposed to make it in a 250 ml solution. Okay, so what you are going to do is, step 1, you are going to take around 50 ml of distilled water. Okay, of course you are going to add water or any salt with the help of funnel. So you are going to add little bit amount of water first. It's around 50 ml, but you need not to weigh it accurately. Little bit amount of water you're supposed to add first. Then 0.25 gram of NaOH you're supposed to add. Okay, of course while transferring, there will be some pellets which remain stick to this side. So what you can do is, you can add further water to dissolve it, and In the solution you will be having a mixture of the water and the NaOH. Now what you have to do is you have to mix it properly. Okay, give it a good shake and then you will have a proper solution, and then add further water. So you have to add water till this point, till this mark. Now in this mark also we have upper meniscus, lower meniscus. So how to which meniscus should we take? It's different for the colorless solution, different from the for the colored solution. So I'll explain that later on. But as of now, just remember that you have to fill the solution till mark, and then you have to close this standard flask and give it another good shake. And that's how you will end up with approximately n by 40 NaOH solution. I hope you do understand why I have written approximately n by 40 solution. Reason being, no matter how much care we are going to take care during the procedure, we will always end up with a little bit lesser amount of the NaOH, or maybe little bit higher amount. It is also possible. Why? Because the NaOH is available in terms of, in terms of pallets. These are pallets, right? So you're going to add complete palette, so normally it can be a little bit higher also. Okay, so that is why after getting this solution we are supposed to standardize it against any acid, any primary standard solution, to get exact volume or exact strength of this particular solution. Okay, so I hope you understood everything that I have explained, and still if you have doubts, like there are so many concepts that I have introduced, the equivalent weight, primary standard solution, and like how to prepare lower meniscus, upper meniscus, all those things. So don't worry about this. I'm going to explain all these things later on in this in the subsequent videos. And if you find like particular topic difficult, or if you are interested in learning some other topic, do let me know through the comments. Okay, and if you think like I should focus more on the practical part or on the theory part, that also you can comment down below. All right, okay, then I'll end this particular video with this. Okay, I'll see you in the next video. Thank you.